Just look at this file. Login functions, customer functions, product functions, order functions, payment functions, email functions, remote functions, database functions. Everything is stuffed into one giant file. Now imagine this isn't 80 lines. Imagine it's 5,000 lines. You need to find a bug. Sounds like a nightmare, right? The good news is Python has a solution. Professional developers don't write everything inside one giant file. They organize code using modules and packages. Instead of putting everything into one file, we split the application into multiple modules. Each module has one responsibility. Now, finding code becomes easy, maintaining code becomes easy, testing becomes easy, and that's the power of modules. Today, I'll show you exactly how Python experts keep huge projects clean, organized, and easy to maintain. By the end of this video, you'll know how to create your own modules, use Python's powerful built-in modules, organize projects with packages, and even download packages created by developers around the world. Let's start with the most important question. What exactly is a module? A module is simply a Python file. That's it. Any Python file containing functions, variables, classes, or executable code can be treated as a module. Think of a module as a toolbox. Instead of carrying every tool in your hands, you keep tools neatly organized inside a toolbox. Similarly, we keep related code inside a module. Let's create our first module. We'll create a file named calculator.py. Inside this file, we'll write a simple function. In the first line of the code, the keyword def means define a function. The word add is the function name. Inside the parentheses, a and b are parameters. These parameters act as placeholders for values that users will provide later. The colon at the end tells Python that the function body begins on the next line. Return a plus b. This line performs the addition operation. Whatever result is obtained gets returned back to the place where the function was called. If a equals 5 and b equals 3, Python returns 8. Now let's use the module we just created. In the first line, import calculator, the keyword import tells Python to load a module. The word calculator refers to the calculator.py file. Python locates the file and loads it into memory. In this print statement, calculator refers to the module. The dot operator means access something inside that module. Add is the function stored inside calculator.py. The values 5 and 3 are passed as arguments. Python performs the addition and returns 8. Finally, print displays the result. Sometimes we need only one function instead of the entire module. From calculator import add. From tells Python where are we importing from. Calculator is a module name. Import add means bring only the add function. Because add was directly imported, we don't need calculator.add anymore. We can simply call add. Python also allows us to use shorter names. In the import statement, the keyword as creates an alias. Calculator now has a nickname called calc. In the print statement, we use calc instead of calculator. Now let's explore some built-in modules. The random module helps generate unpredictable values. This loads Python's random module. Random method generates a random decimal number. The value will always be between 0.0 and 1.0. Randint stands for random integer. 1 is the starting value, 10 is the ending value. Python picks one whole number between them. Next is randrange. This works like range. Python creates 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Then randomly selects one value. Next is choice. First we create a list. The choice function picks one random element from the list. Next is shuffle. The shuffle function rearranges the items randomly. Next is math module. Import math loads the mathematical functions provided by Python. SQRT means square root. Here, Python calculated the square root of 25. Next function is factorial. Factorial means multiplying all numbers from 5 down to 1, which means 5 into 4 into 3 into 2 into 1, which is equal to 120. Next is seal. Seal always rounds upward. Floor. Floor always rounds downward. Next is power. 2 raised to the power 3. That is 2 into 2 into 2, which returned 8. So the output is 8.0. Next module is statistics. This module helps analyze numerical data. Mean is the average. The sum of all the numbers is 150, which is divided by 5, hence returned 30. Next function is median. Median is the middle value, which is 30. Next is mode. Mode is the most frequent value, which is 2. Next function is standard deviation. Standard deviation measures data spread. Next function is variance. Variance also measures how far data values are from the average. Next module is OS module. This module allows Python to communicate with the operating system. Get current working directory returns the folder where Python is currently running. Next is list dir. It shows all files and folders in the current location. Next function is mkdir. It creates a new folder called employee data. Next is rename. It changes a file name. Next is remove. It deletes a file permanently. Next module is datetime module. This module helps us work with dates and times. Datetime.now returns the current system date and time. Next function is today. It returns today's date. Next function is strftime. %d means day, %m means month, %y means year. strftime formats the date. Notice that your output will be different from mine because this function always returns the current date and time of the computer on which the code is running. Since I'm recording this video today, my timestamp reflects the time of recording. When you run it later, you'll see your own current date and time. Next function is strptime. This converts a string into a date time object. Next function is time delta. Time delta represents a time difference. Here we add 7 days to the current date. Next is creating your own module. Now you know something important. You are not limited to Python's built-in modules. You can create your own reusable modules exactly like professional developers. What is a package? As projects become larger, we end up creating lots of modules. Now we need another level of organization. That's where packages come in. A package is simply a folder containing multiple related modules. Think of modules as books. A package is the bookshelf that keeps those books organized. Let's see how to create a package in PyCharm. Click on File, then New Project. Create a project named Modules and Packages Demo. You will see something like this. First, I have created a new PyCharm project named Modules and Packages Demo. Currently, it contains the main.py file. In PyCharm, creating a package is very simple. Right-click on the project, choose New, then Python package, and give the package a name. PyCharm automatically creates the package folder and the special init.py file. You will notice a file name init.py was created automatically. Traditionally, this file tells Python that this folder should be treated as a package. Modern Python doesn't always require it, but most developers still keep it because it clearly identifies the folder as a package and allows package initialization code if needed. Right-click on the utilities, click on New, then Python file, give it a name, calculator. Inside the calculator module, I am creating two functions, one for addition and another for subtraction. Here, we are defining a function named add. The values a and b are parameters that will receive input from the user. The statement return adds the two values and returns the result. In this line, this creates another function named subtract. This returns the difference between the two numbers. Next is using the package in main.py. In the first statement, the word utilities is the package name. The word calculator is the module inside that package. Add and subtract are functions inside the module. Python follows this path: utilities package, calculator module, and add and subtract functions. In line 2, this function call passes the values 10 and 20 to add. The function returns 30 and print displays it on the screen. In line 3, this function call passes 30 and 10 to the subtract function. The function returns 20. Here is the output of the program. You can also write in this style. Instead of importing specific functions, we can import the entire module and access its functions using the complete package and module path. So this is the final project structure. Calculator.py is a single Python file containing code. Utilities is a folder containing one or more Python modules. Next are external packages. Here's the coolest part. Millions of developers around the world share packages publicly. Using PIP, Python's package manager, we can install ready-made libraries in seconds. PIP is Python's package installer. Install means download and install. Requests is the package name. Let's quickly recap everything. A module is a single Python file that contains reusable code. We learned how to import modules, import specific modules, and create aliases. We explored powerful built-in modules including random, math, statistics, OS, and datetime, along with their useful functions. We created our own custom module and learned how packages help organize multiple modules into a clean project structure. Finally, we saw how developers can install external packages using PIP and gain access to powerful tools created by the Python community. If you understood modules and packages, you have learned one of the most important concepts in professional Python development, because this is exactly how real world software is organized. Thank you for watching, and I'll see you in the next Python lesson. Happy coding!